All right, good afternoon. Happy Friday. Welcome to the deep dive. We around the chats here. Right. Welcome, first of all, and thanks for watching, anyone who is here. If you are new, haven't caught this stream before, first of all, thanks for checking it out. My name is Tim. I go by Foamy Guy on GitHub and Discord. You are watching the Deep Dive, which is a weekly live stream program where we are working on CircuitPython stuff. If you don't know what CircuitPython is, you'll learn more at the main website for it right here, circuitpython.org. It is basically a version of Python that runs on tiny computers called microcontrollers. And excuse me, on this stream, we are working on the software surrounding CircuitPython, either the core of CircuitPython itself, the C code that actually runs on the microcontroller and interprets Python for you, or libraries or examples or projects or other infrastructure bits related to the project. And today I have some library and some example work queued up. I have been working on the driver, the CircuitPython driver for the OPT4048. And so we are going to work on the driver a bit and work on an example that uses a web server. But before I do jump into that, let's finish up the intro. So all the different CircuitPython devices are listed here. CircuitPython.org is where you can go to learn more. As always, huge thanks to Adafruit. That is the channel that we are streaming on right now. So for anyone that doesn't know, Adafruit makes CircuitPython possible by paying the team of folks who work on it, including myself and Scott as well, the lead developer, Scott Shawcroft, who ordinarily does the deep dive, but he is out on parental leave, so I'm here filling in. So huge thanks to Adafruit for paying myself and the team of folks who work on CircuitPython, and thanks to anyone who purchases hardware from them, which is one of the easiest ways to support what they are doing, including funding CircuitPython. What is up to be Autograph over in the YouTube? Nice to see you, my friend. And David Glauda on Discord. Is this Tristimulus? It does. Yeah, it says Tristimulus. If I'm honest, I don't know exactly what that means. XYZ, I guess. It does have 3 values, or there's actually 4 values. But there's a couple of different ways you can read them. And then, yeah, there's kind of... I'm uneducated on the color theory and the light theory and the stuff kind of really low level that goes into this sensor, but I have had success porting it since the Arduino one was already done, and I had a reference point to kind of test against and work against. Oh, chat is cut off. Let's see. I have a very dark room waiting for me in those for one of those sensors. Nice. I have a very dark room waiting for one of those sensors. Yeah, it seems like a pretty cool sensor. I've got some ideas to tinker around with it. Let me see if I can fix the chat. Oh yeah, it is. Okay, let's just make this a bit shorter. Thanks for the heads up on that. I appreciate it. And let me know about the chat. Here we go. So yeah, it is Tristimulus, but if I'm honest, I don't really know what that means. I mean, tri obviously is probably 3 of something, but stimulus, 3 stimuli. It has 4 channels. It takes 4 channel readings. But yeah, I don't know exactly what that means. All right, yeah, we said thanks to Adafruit. We talked about the sensor, so that is what we're working on today. So I will start real quick with what we have so far, and then we'll jump in and start working on the new example that I want to make. So I'm actually going to swap over to the web serial example, which is closest to what we're doing. Let me keep this one actually, because I finally got this working. This is the interrupt pin. 448 interrupt pin 30 of file. Why would we not be able to? Well, truthfully, we're gonna end up changing to another microcontroller. Maybe we should just do that right now. Copy. I mean, is the drive? Of course, I don't. It's true. Say. Alright, let me just try re-plugging it in. That's better. Stop it as fast as it can. There we go. With the web serial test. So this one is basically just going to read data from the sensor and print it into the serial console. But there is another program that goes along with it, which is going to read the data out of the serial console in this format. Actually, let's just leave it running. Let's exit TO, because we can't have TO running while we do that. Let me get a Chrome window, because it does have to be Chrome. Well, maybe it doesn't have to be Chrome, but it can't be Firefox, and those are the two that I have. Go to here to find the right thing. I put a link. There's already a link, I think, in the example. This is Arduino example that I have made the CircuitPython one. Really what we're after is this. Okay, so we have this nice web app here. We can go connect to Arduino. It says Arduino here, but it's just hard-coded for that. Technically, this has got CircuitPython on it right now. So this is CodePy. It's connected as CircuitPy. The drive, the actual device is right now a Feather RP2040. And it's got the OPT connected over Stemma. And actually the interrupt pin is also connected there, but we're not using that right now. This one will just take a reading, print all the data out, and then just loop over and over doing that. And then on the web app side, once you connect, we choose a device. It looks like it's actually crashed. Why did this crash? Auto reload is on. It seems like we're in the REPL for some reason. Maybe I didn't start it running. Well, we could just reset maybe. I'll just press the reset button. There we go. All right, so now that is getting data coming into here. Oh. Okay. That's why we ended up in the REPL, most likely. Let's fix that, actually, before we go any farther. So sometimes when you try to read data, it doesn't work. It has like a checksum, and if the checksum fails, it raises a runtime error. So let's catch that and just pass error reading data. We don't really care. We can just read again next time. All right, and then what we can do to like actually see this working is I'm going to plug in another device. So I have kind of standing up here next to this, I have another device which has a bunch of NeoPixels on it. Another feather with a NeoPixel feather wing. So we're going to plug that in. And it's probably going to turn on. I don't remember what the code is. Yeah, it looks like it's got some code on it. It's just, actually, it's cycling through. Let's stop doing that. Let's just go to one color for now. Turn off the loop and just set it to one color for now. Okay. All right, so neopixels are green, and if we go back to here, that is now sensing the green color, and it shows green down here, although I have to zoom out to see it because my font size is kind of big. And if we change that to a different color, so like I'll put this over here, put this over here, we could change this to like red, for instance. Save that, and now the sensor has noticed that we switched up to red. Wait, is there a green LED next to the color sensor? There's a green LED on the breakout, yes. There's a power LED, which is pretty customary for stemma breakouts, but there is a little trace. If you don't want it there, you can just cut that trace. And then my assumption is that it will not turn on anymore, although I have not tested it, obviously. But I don't, like, this little LED is kind of hidden behind the stemma connector and the main sensor is here. I don't know that it really picks up the green. Because you could even see, for instance, like, if we unplug, like, if I unplug this, that we don't have that on, and now that little green LED is the only light that's really by the sensor. But if you look at the thing here, oh, actually it crashed. Or it disconnected. Plugged the wrong one. I did not unplug the wrong one. Or why it unplugged. But anyway, I can reconnect. And it is just reading white, kind of regular light or whatever, right? Basically just ambient, no light, essentially. So it's not like really skewed towards the green. So I don't think that little green LED affects it, but it is there. And you should, I believe, be able to cut the trace. Okay. So this is pretty cool. And the way that this is actually working is through web serial. That's the name of it, web serial here. That's the name of it over there. We copied the file named web serial. And it's just obviously printing in the CircuitPython code, which by default in CircuitPython comes out the serial connection. So this is then connecting, reading that data, parsing it out to get the XY, which plot to this chart, and to get the lux, which is like a measure of how bright it is. And then it gets the color kind of mapped from there as well, due to that chart, the XY values. So I would like to host this on the device itself if we can. I would like to at least try, because right now we are viewing this page just live on the internet. It's hosted on GitHub.io just as a GH pages. But I think we could probably just host it on the device also, maybe. So that would be cool. So I am going to undo, excuse me, I'm going to undo my changes here. I don't really know what I changed. I'm going to go to GH pages so we can get the web serial code, the actual web app. We need to use a different device because RP2040 doesn't have internet. I have a Feather P32 we could use, I think. Oh. Interesting, that came straight up to a bootloader. I must have had the button pressed or something. It came up to CircuitPython. Alright, okay, that's disconnected. Let's reconnect here for now. That's on 921. Let's update that. This is a Feather S3 EFT. Right from that camera angle, didn't feel wrong to do that, but Lydia did think about everything. Yeah, it's definitely on top of things. Oh, actually, oh, that's the wrong way. Right. We need to double tap to get to the bootloader instead of boot button, reset button. Boot button, reset button goes to the ROM bootloader. Different place, different way that it would need to be flashed if we wanted to use it. All right, so we'll paste that. This should update us to 10.06 alpha 6. And then I want HTTP server. Gonna just grab. Actually, I'm gonna grab. Always do this. Is there not a WebSocket one? I don't really. I wanna. I have run into this a bunch of times now. I should PR a non-async IO example. I know that I have one somewhere, but I don't know where. I don't really want to just go hunting for it. All right, that's updated. Maybe we'll try async IO. Maybe it doesn't matter. I just save actually just. I'm gonna make. Actually, we can just paste web serial. Well, eventually it's gonna be something else. That's fine. Doesn't. Web serial. That here. I think we could make this like. Tell it the folder that it should serve from, and then we would not. Well, maybe we want to do that anyway. Yeah, maybe we don't do that. Maybe we do a file. I think we can do a file response. So let's say web serial. So it's gonna work kind of the same way as the other one. / web serial. I think there's a file response. Pass it. Request file name equals root path. We have request file name equals web serial index. You know what? We need to host the directory though, because it's also going to try to fetch the JavaScript. And we need to make sure that we serve that. All right, so we need to actually initialize this with, I don't know what it's called, static dir maybe? Root path? Yeah, root path. I think we need to do root path and then web serial. We might not even need a view. Web serial. Out this and see what happens. no module async IO, lookup install auto. Okay. Supposedly we have a server on port 5000. And if I go index.html, we got the page, nice. And did it get the JavaScript? I don't know if the JavaScript, well, honestly, we might not have because that's broken, right? Let's look. Oh, actually, the microcontroller does believe that we served the JavaScript. Why the button didn't? That failed this time. Oh, there we go. Close this so that I don't get confused. Get the wrong one. Interesting. That's fascinating. It doesn't know that it's in Chrome. Okay, my next kind of like gut instinct is that it's maybe not supported on HTTP. It either has to be HTTPS or I think it can be file as well, because I'm pretty sure I tested this yesterday with just opening the local file, which is interesting. But in any case, honestly, we don't care about this because my whole intention is to use WebSocket instead of Serial. We're going to go back to this, and actually we're going to go to the JavaScript. We are going to look at the code here, which was initializing the WebSocket. We're going to put that in the JavaScript. Actually, we're going to get rid of all of the USB stuff and command. I don't know what commands you can send. Serial data, read serial data, disconnect, connect. I think what we're gonna do is I think we will keep process serial data, but get rid of all of these, and then on our like on message for WebSockets, we will call process serial data and we'll send it what came in over the WebSocket. And then this is doing what? Okay, yeah, we can get rid of all of this. We're trying to use serial stuff. That's why the button didn't work though, and that's why we got this. Technically, what happened? Serial was not in Navigator. That's why I got the message. My guess is that it limits it to HTTPS or file, I guess. I don't know why they would do file. They assume it's local. Well, it's not local. Maybe localhost would work. In fact, I could have been on localhost before. I don't know for sure that I was in file. Test points. I don't know what those are for. We can leave those for now. Comment them out to start. And then we want our WebSocket setup code. So this says open is just going to print, close is just going to print. On message, that's where we want to call process serial data. And we want to pass in event.data. Well, okay, event is gonna get passed in, so we... Okay, I see. Let's actually make function ws on message event. And then what we'll do is we'll set that to this ws on message. And that's going to get the event, and then we're going to call process serial data with event.data. Error. Don't really have this. Let's just console log. What was that? Error, okay. Console.log. Okay. So we can run this and see what it does. I think it's not going to work because we're not actually sending any data yet through WebSocket, but we can run it and see if the WebSocket connects or not. Connect WebSocket 101. That looks like a successful WebSocket connection. I should turn off auto reload because otherwise this is just going to keep getting interrupted. Let's make boot.py import supervisor supervisor.runtime.auto reload false. I'm going to save that. I'm going to reset button once right now. Okay, and then really what we need to do next is send the data into the WebSocket. So the original script was just printing. We now want to go, well, also the original script is gone, so let's get the code. Ah, right, that's on a different device. Get from here. Okay. Let's keep basically all of this. So we get the read interval, the sensor setup. This is basically part of the setup as well. And we're gonna need like a figure that out later. We're gonna need an async reading function basically. Okay, that will at least initialize the sensor. And then this is doing while true, and so we want to pretty much do the same kind of thing, but that mean it's going to run once per second? I think maybe it does actually. So I think we could actually put our code in here. I'll keep this, but this could be wonky now. I don't know that this is necessary or good at this point, but let's see what it does. And then instead of print, though, we want to basically get this to be the message we send. So out message, I'm going to shorten it, MSG out message equals, but it's going to be a bit rough because we're going to need all this kind of stuff going on. Equals honestly, I think this should just use JSON. But I did not make this part of it. Because this could just dump JSON, right? And then on the JavaScript side, it can parse it with just JSON.parse, but right now it's kind of got this whole line parser data buffer thing going on. Those are new lines. That's a new line as well. And that, actually, we want a new line also. All of those are new lines because they all were print, and print automatically puts a new line on them. Okay. We don't need this, and then we will send the out message, but it's already a string. Silently through, yeah, I guess so. Let's try that. Oh, right. Auto reload, auto reload is off now, so let's actually restart it. No module. Okay, let's do. So that's actually not going to succeed if I do circup install because the library is brand new and it's not in the bundle yet. I submitted the PR to add it to the bundle earlier, and it needs to get merged, and then overnight is when the bundle gets built. So circup, I'm pretty sure, just downloads the latest built bundle. So the next day after it gets added is when circup will be able to do it. So I'll paste that in. Let's see if that gets it to run. Okay, server is running here. This seems like it's connected. Be able to see more traffic if it were actually connected, though. And it doesn't look like data's coming. Oops. Okay, actually it crashed. 18 send WebSocket. Last read time. Variable reference before assignment. I guess last read time doesn't exist. I think 0. Oh, but it's well, it's a variable, so it's going to be trying to set it as global. Yeah. Okay. Data class data. There. Need an instance, or need an instance actually? Actually, I don't know if that's right because it looked like it was set, but okay. Didn't crash this time. This? Have data? Oh. Okay. Now we have data coming through. Sweet. Is it updating the thing? It's updating the thing. Look at that. So that's there. That's in the center. If we turn the colors back on, I will try to do without wrecking my entire desk. Whoop. I don't have the camera hooked up anymore, but we'll see this jump if it works. Well, I mean, the camera's still hooked up, but the tab is hidden. All right, so that bumped over to red. Oh, okay. Also, I moved the sensor kind of far away. Got everything all jostled around, which is why the red was way more red before, and also why it's way more red again now. All right, sweet. So that is working through the WebSocket instead of the web serial. It's all hosted from the device instead of needing to be USB. So this could actually run off a battery. You could connect to it off of another computer on the Wi-Fi network. Needs indenting, out message not available. Indenting. Out message is only created here. It should probably be like We want to be propered. Oh. Oh. It's not JavaScript code. Yeah, it does get created here though. I think it must have been last read time. I am confused about, I mean, maybe async makes it different. Like, I thought there was a last read time. I mean, yeah, because all I did was indent this into a class, and then now we have an instance. I guess it's not able to see that, or else it was read interval, or else the line number was wrong. I don't know. Those are my, not really sure why that worked. Well, I know why this one worked, because it's no longer a global variable issue. I guess the part that I'm really confused about was it should have been mad that we were trying to set it, maybe. Because you can access global variables, but we are in a while true here. I suppose there's no telling. Actually, that could be. Maybe the order. No, but that was way. I don't know. Yeah, I don't know how async does everything. Maybe it got done out of order, though. Run main, but all of this stuff should be before main. In any case, it is working now. And we could change the color. Make sure that it picks up the new color. So if I go back to here, I can go code and put this on. One thing I noticed actually is that blue, let's try it. Let's see what it does. Blue, I think, runs out of the graph. Yeah, if you're like, if you give it really, really blue. And there it is. So that's like full blue, obviously. Although the brightness is still fairly low. This is not, we're not like, yeah, 2% bright. Yeah, I usually go really, really, really low on NeoPixels. I tend to find even like 10% brightness is like very bright to my eye. Ignore me, I thought it was, I gotcha. Potentially undefined at send message would be non-local global. Last read time at the top of the function. Fixed it. So last read time, I mean, honestly, last read time, I don't even think anything is using it at this point. I could just get rid of it. But I will say it wouldn't work so great if it was only declared in the function, because its purpose is to be able to compare between calls, or that was its purpose before it stopped getting used. There was at one, in fact, does the Arduino one have this? Let me look at the Arduino one. This different one of these. This might have actually just been from a different example, honestly. Maybe this is not even part of this example. Does this one do last? Oh, it does. Okay, so last read time. Well, okay, yeah, it's using it to affect the read interval, but the truth is this sleep here is making it so that that's kind of irrelevant anyway. So I think we just do none of that. Let's bring that back, and then the sleep can actually just be read interval. I will say the read interval should be, so this is set to 0.1, but this is set to 100 milliseconds, and the conversion time is per channel, and there's 4 channels. So this is actually going to make it take 400 milliseconds to get one reading. Which makes the read interval, it doesn't need to be that low. I'm not sure what it will do. I guess probably just get repeat data. All right, let's try rerunning this and reloading this. Okay, blue is still running good. So yeah, now this is going much faster now. I don't have a good way to stop it. I guess we could do that. I'm gonna say, is it changing it is changing every data as well, actually, which is interesting. I was gonna say, I would think maybe that the numbers might not change because so Lux, for instance, is not changing every time. I think that might be because of the read time, conversion time. I picked up some sheets of tinted screen protectors to deal with the brightness issue. Oh, that's a good idea. Yeah, I do. I throw paper on top of it sometimes. They have that acrylic, which makes it look pretty sweet, but I do not have any of that stuff. I should get some of that. It's a tinted screen protector. Would be a good one as well. So is the sensor get CEI blocking, or is it effectively stopping? I mean, it blocks. I don't know is the short answer. I don't think it blocks. I think that it gets old data if there's not old data, but I'm not positive. We could look. There's nothing that's intentionally trying to make it blocking, I don't believe. So get CEI, CIE calls get channels raw. So that's where the data comes from. Everything else in here is just processing the data to get it into those three values with magical mathematics. But get channels raw, where it gets the data, is from all channels raw, which is a RW bits that's large. It's reading 8 bytes. No, 16 bytes. Reading 16 bytes, and then it's got all this stuff to like split them out into 4 channels, and then within each channel there's 2 bytes, and within each of those 2 bytes there's like exponents and mantissa values, and there's checksums and other stuff. What all this is dealing with. So I mean, it's blocking insofar as RW bits, when you access it right here, that's going to take however long the thing takes to respond to you over I2C. But I don't think that it blocks for the whole conversion time. I think that it gives you old data, which is why I thought maybe these numbers might not change. And it looks like sometimes they aren't. Like those are the same values, for instance. In fact, all of those are the same. So yeah, I think sometimes you would get the same numbers on subsequent readings if you are calling like get CEI, get CIE. If you're calling that faster than conversion time times 4 plus a little bit, because there's also a little bit of overhead that's something else. The registers might as well contain old data while the new. I think that's true, but I don't know it for a fact. And I also don't know how to read the data sheet enough to like understand for certain. But that is my take. What I do know is that you can call get CIE, and by extension get raw channels or whatever. You can call those really, really fast, like on the order of 10 to 12 to 15 milliseconds in between. You can call it and you'll get data. You'll get something. And it might be repeats or whatever. There's also, you can go way faster too. So right now it's set on 100 milliseconds, but that's actually on the slow side for the settings, honestly. It's got, it can go really fast. What do they call that one? Time, conversion time. 600 microseconds on the low side. And again, that's per channel. So that's 4 channels total. So, 2.4 milliseconds total to read 4 channels, or 1 millisecond, again, per channel. So 4 milliseconds to read all 4. And 100 milliseconds is like almost one of the longest ones. I mean, it is one of the longest ones. It's towards the end. Okay. With the time we have left, about 15 minutes, let's clean up this thing a little bit. We don't need the disconnect button. We don't need the connect button. Let's get rid of those. That is going to be on CircuitPy, Web Serial. We should change the name of this so that it's not Web Serial ultimately. Maybe we'll call it what? I don't know, color sensor? WebSocket sensor? WebSocket color sensor? Yeah, okay. I think... But Okay, so we don't need connect. We don't need disconnect either. We don't need clear. Actually, I want clear log. Oh, it must get hidden. We'll leave that. This will probably make the JavaScript mad. Well, you know, to the extent that JavaScript ever gets mad instead of just continuing on. Let's reload this. Oh, one thing we could do is on WebSocket disconnect, we could hide the marker, which I think it does do for the web serial one. Does this work, clear log? Doesn't look like it works. Stop this so that I can see. Yeah, it doesn't work. Actually, you know what? Probably just the JavaScript is sad. Like I said before. Probably something tried to access a button, failed, and then the rest of the JavaScript do anything? So I stopped it. I wrecked it by reloading. Let's try to load kind of. Crash? Rolled too fast to actually see anything. When I okay, why does this get hidden when I click this, but it's not on top of that? Script, what is reading the clear? Nothing uses it. I swear that it worked. Well, I took everything out that uses the connection. Well, that's weird. I mean, I'm sure that it worked before those. It's strange to me. Let's go here real fast. Okay, there we go. So it was inside of if the serial gets found, like if serial works, then it sets the event listener. But I did axe that entire section out, so that's why it's gone. And I didn't even comment it, I straight up deleted it. So we'll just say, matters where. Set it up somewhere. And do we still have clear log? I think we should. Yeah, add to log, clear log. There we go. Now it's working. Cool. Here, we don't have disconnect. Connect. Status? I don't think we have any more. Status, yeah, that was connection status. We don't need that. Well, actually a WebSocket Actually, it might be nice to show the WebSocket. I don't know where the, oh, it's right there. Okay. Yeah, let's change that actually. That'll be easy. Script, we can just say, whenever that thing gets connected here, let's print this, and also, you can do this, right? I think you can do this. Let's print this and also go status display dot text equals connected, and then we might as well do it on close also. Got an extra one of those. Not connected. Semicolons, even though they don't matter anymore. Theoretically, we could get it to show not connected now by closing the connection, which the easiest way to do, I think, is kill the server. Yep, there we go. And then there's no reconnection logic, so it's not going to reconnect unless I refresh, but I think that's fine. Does this color come out? Yeah, so this got the color, but it just, for whatever reason, it gets cut off on the graph. I've noticed blue is really the only one that does that. Well, the only one that I've seen. Okay, cool. This is awesome. This is exactly what I wanted, was to be able to take this example and move it over to where the web app is actually hosted from the microcontroller itself rather than on the internet or on the local network or whatever. It's actually hosted in a web server on the device, which I think is super cool because it's the same device that the sensor is already on. And the connection then doesn't have to go over USB. The connection to get data can just be internal on the microcontroller. In this case, it's choosing to do that connection over WebSocket in the web server. There are other ways that could be handled, but this one seemed nice and easy. Turned out nice and easy, so I'm very pleased. Is there anything else we would want on this? Is there any reason we would want a disconnect button? I guess we could have disconnect and reconnect. I kind of like the just auto connect when it loads and disconnect if it disconnects and you need to refresh it. The other one doesn't work like that, but the other one you have to like select your device and stuff. It's kind of a totally different paradigm, truthfully. I think I'm just gonna leave that this way. You know, one thing I would like actually is this stuff to fit better. It's kind of nitpicky, doesn't really matter that much in the grand scheme of things. But I noticed like we have a lot of space down here, and this is below this like bar thing here. What if it was two whole columns? What if we had column with this, column with this? That's going to end up splitting to a second line, most likely. Then we have like a vertical column break is here. This can then go up, and that would give us a little bit more that we would see at the bottom. There's only 5 minutes left. I don't know if I'm good enough at CSS for that. Okay, actually, we're a little bit in luck because we could just take this and put it inside of controls, and I think it will work because of the way the CSS is already done. So if that's true, then hallelujah, we lucked out quite a bit actually. If I take this and I just drop it in controls, I think we will get what I'm... This did fail, CRC check. We should have that try catch thing, technically. We don't really need to get that. We're just gonna pass. Error reading sensor. Nice. It's not quite enough to get it up there. What if I pull this though? Yeah, so if I'm full screen, it's enough. Which is good. That's better than it was. Yeah, I like that better because we got plenty of room there. We're not like pushing this too far. Oh, actually, we can keep that all the way until there. Oh, it's whenever the K breaks. I see. Whenever this breaks to a new row, that's when we lose it. Like right around halfway. We do lose a little bit. No, we don't. At full screen, we don't. Would be nice if these were aligned. Why those would actually be different. One of them not an H1? That is an H1 and it has margin N. That is an H2 and it does not have margin 10 stuff. Okay. Is that actually on the tag or? I mean, maybe they should both be H2s instead? It's practically. Oops. Oh, that changed. There we go. Okay. If we really wanted to, we could like not center this in its column. This could be left or right, doesn't matter. And then this stuff could be like alongside of it, instead of below it, and then it would fit even shorter screens. Although if you got too narrow like this, it would get messed up. But it could always still revert to this. But like CSS, you know. I don't know how to make it I don't know how to make it do all of that. I know that that's all possible with CSS, but I do not know the correct way to do it really. Oh, that's the not a 502 response, but that's must be, I guess, the size, number of bytes, I suppose. All right, let's change this again so we can see that change, and then I think we'll be wrapping it up here. Be quick after that. I should be back next time, next week, I should say, at the usual time for deep dives. So 4 p.m. Central is what time I bill it at usually. 2 p.m. Pacific, 5 p.m. Eastern. What's it look like on the phone just using DevTools? Like on the phone. Oh, what you're saying? Maybe this thing. One thing is it doesn't like to scroll. I noticed. Not like well that right there scrolls. But the rest doesn't. There must be, I think there must be overflow false or whatever, right? Overflow none? Yeah. I think that needs to be not that in order for scrolling to work. Also probably on the container too. And maybe on some of these things also. These are enough. Controls is not gonna go anyway. Actually, visualization we probably. There we go. Now we can scroll. Actually, that's probably gonna fix the thing on full mode also. Get out of this. Ah, yeah, that makes this scroll too. Actually, I think that's better. Maybe refresh the dev phone. Oh, yeah. Someone. Sorry, slow YouTubes. No worries. Yeah, I do think that's a positive change. I'll have to go back and make sure that we didn't break the big one, but that's definitely good. That's definitely better for phones because it gives you the ability to get down and actually see the diagram and stuff. And I think it will be better for desktop too, but I'll have to make sure that it didn't break anything. All right. That is it for tonight. Like I was, I think, saying, I'll be back next week at the usual time, 2 p.m. Pacific, 5 p.m. Eastern on Friday for the deep dive here. For anybody who wants some morning time CircuitPython action over the weekend, I usually stream over on my own channel on Saturday mornings at 10 a.m. Central Time. So Saturday, tomorrow, 10 a.m. Central Time, I'll be over there. I usually drop links in the Discord when I'm getting started. I did actually forget to do that last week, so if there's anyone who watches the Discord for links and missed it last week, that's my bad. I will try to remember to do that like I usually do. But otherwise, I will bid you farewell. Thanks for hanging out. I hope you all have a good rest of your Friday evening and a good weekend and all of that. And I will see you next time. See you, bye.